So the main purpose, two purposes. One, we learn linear combination of random variables in Minitab. Okay? So Minitab. So Excel also can do similar thing, but it's more complicated. So we just use Minitab. And also, if time permit, we can work together on simulate a binomial random variable in Minitab. Okay. So what we are going to do, the first thing, generate normal distribution. Okay. We like to generate two different random variables, both follow normal distribution. Okay. And then we add these two together. And also we can subtract to see, we add on the result, the new random variable. So what's the distribution of a new random variable? And then we can go back to the formula to verify. Does the mean exactly same follow the formula or the variance follow the formula? So I list the sort of procedure here. You can follow me to work on this. So first thing, we like to Minitab generate 200 values, data value. So this data, this random variable, follow normal distribution. Mean is 10, standard deviation is 3. Okay? And we call this random variable norm1. Norm1. Okay. Put here, let's see. So the first, we need to generate a column with 1000 data value. This data follow normal distribution. Okay, so we call norm1. We also need to generate norm2. Okay. So now how we generate, we use calc. So on the Minitab menu. And then we go to random data. So it says the data follow normal distribution. We click normal. Okay. So we can generate number of rows. We want 2,000. 1,000 or 2,000. Let me double check. Yeah, 2,000 data points, like value, rows of data, and we stored this data in norm1. Mean is 10, standard deviation is 3. Okay. And we click OK. Now we generate one column with 2,000 data points that follow normal distribution. Mean is 10, standard deviation is 3. Now next, we need to generate another random variable, still follow normal distribution. We call norm2. Mean 30, standard deviation is 4. Okay. So we go to calc, random data, still follow normal distribution, still 2,000 data points. So this time, we double click norm2. Mean is 30. Standard deviation is 4. Okay. Now we generate another column. So for this one, we call norm sum. And we add together. So how we can do that? We can use calc. We have a, let me see. So this time we use the calculator. So calculator store the result in norm sum. Expression is norm1 plus, you just use plus sum plus norm2. Okay. So this calculator allow you to see, have a lot more math functions toward one random variable. Okay, now we just click OK. So this one, see the first one is the norm1, the first row, the data add together. And this one, the second row data add together. Okay. So we like to know what's the mean and what's the variance. Okay. So we look at what's the formula. Okay. See the formula, if two random variables, this A x plus by, just mu x plus b mu y. So in our case, these coefficients both are 1. So x plus, just mu x plus mu y. Okay. And also the variance variance just because our C, the coefficient is 1. So it's just the individual variance add together. So further, if it's it's normal distribution, we have a specific formula for the normal random variable. The normal random variable. So if two random variables add together, it also follows normal distribution. So the mean is the individual add together, the coefficient plus the individual mean add together. Variance, the coefficient will be squared, and all this variance add together. And it's follow normal distribution. Now we will verify. Okay? So this norm sum. So first, to see how we verify. We find out what's the basic statistics, mean and variance. Okay. So this time I just add one more. And what we like to have, we just copy this one. Excel, we have a separate sheet for the norm 1 plus norm 2. So the statistic here, we did the simulation. Okay. So norm sum, the mean should be, so theoretically should be equal to 10 plus 30, right? Equal to 40. Oh, yeah. See, this is the 40. This is very close, right? Mean of the norm sum is almost close to mean of norm 1 plus mean of norm 2. Okay. So you can verify this. This is 40, around 40. So how about the variance? So the variance from the formula will be variance of norm 1 plus norm 2 should be equal to the variance of norm 1 plus the variance of norm 2. Okay. So you can highlight this so you see the mean. We don't have variance, but what we have the standard deviation. Okay. So we need to here this variance. The variance equal to the standard deviation squared. So you look at this, you sum all this together, that's 25.86, and this is 26.3. It's quite close. So from the experiment, we found out the variance of the norm sum equal to 26.3, and then the variance of norm 1 plus variance of norm 2 equal to, just put here, equal to, you just add these together. It's missing. Equal to just this one plus this one. So it's quite close. Okay. So the variance, copy. Is very close to very close to the sum of norm 1 and norm 2. Okay. So this is just to verify the formula. And also what we need to show the histogram here. That's the norm sum for normal distribution. We look at the shape. Okay. We use histogram to see what's the So two normal distribution random variable add together. This is the shape. Okay. So it's not perfect smooth shape, but it's quite close. Okay. So we can copy this one here. Here. Now, next question. So how can I Excel? Okay. Now, I have a question. Can we tell is it really from normal distribution or not? Okay. We can use, we call probability plot this time. Okay. So the probability plot, we go to stat, basic statistics. We have normality test. Okay. So normality test, let's just tell you, is the data from normal distribution or not? Okay. We just click variable. Yeah, the others we just keep as default. Okay. Okay. So this is the probability plot of the new variable. Okay. So since this is almost straight line, okay, so this follow indicate the data is from normal distribution. What we want this one here. Just paste. Okay. Since the probability plot, yeah, shows a straight line. This means the data is from a normal distribution. So now we verify if it's normal distribution, if both are normal distribution, the linear combination of the normal distribution random variable, the result still follow normal distribution with the new mean, which is just individual mean add together, and the new variance is the individual variance add together. If there are some coefficient, the variance coefficient will be squared. Okay. So any questions so far? So we have finished. One thing is here, we generate the two normal distribution random variable, just just the two columns, 2000 data value from the two different normal distribution, and we add them together, and we verified the mean will be the individual mean add together. The variance, you can highlight this, the variance also the individual variance add together. We also verified, use the normality test, the result, the new random variable follow normal distribution. Okay. Any questions? Okay, good. If no questions, we can do again. If we subtract, okay, instead of add together, okay, norm 2 subtract norm 1. So we'll go back here. We have one we call norm difference. Okay. So we generate this one with, and also we look at what's the mean and what's the variance for the new random variable, and also what's the shape, distribution. Okay. We use calculator to generate this one. So this time we're interested in difference of these two. So norm 2 subtract norm 1. Okay. Click OK. So you see the value here. So this one, the difference is the difference, like norm 2 subtract norm 1. I have a question for you. Is it possible my norm difference could be a negative value? Anyone? It could be I happen to have some very small value, 5, and this one maybe have a larger value, 15, so it could be a negative value. But here you couldn't, yeah. Since it's happened very, unlikely, but it could be. Okay. We're trying to find out the basic statistics, the mean and variance. Okay. Let's see. We use stat basic statistic display. This. Okay. So now we want the norm 1, norm 2, and the difference. Okay. And then we can copy this one back to here. We have the different norm 2 subtract norm 1. Just put here. And we are interested to see, can we verify? Okay, so the difference, this is, you can finish the rest. Okay, you need to, okay, not the max. You need a variance. Okay, the variance will be the standard deviation squared. Okay. And then to see, hey, the variance is very interesting. As the variance is the difference, so this is the mean, this is the variance. See, the variance is also the variance put together. Okay, it's not the variance, is the difference of the variance of the two. The variance is still these two add together. Okay, so this is a very important observation. Okay, the variance is always add together. Because this C could be negative value. So this is the very important part. So you need to do this, and also to see this is verified. The variance is these two variances add together. And also you need to draw a probability plot to verify that's the difference from normal distribution. You use this basic statistics normality test to test this difference. Okay, so the difference is also straight line. Okay, so here copy. So for this one, you need to put. So besides, you need some wording here. I'm not going through. You also need to put the graph, the probability. So tell us the, it's still the difference is also follow normal distribution. You also, can graph the histogram here. So the whole purpose, I need to compare. So I like to have the histogram, the x-axis, the scale goes from 0 to 50 for all three histograms. So I can compare. Okay, this is also from 0 to 50. So I can click OK, 0 to 50. And then I can copy this one and back to, and then the norm 1, this is norm 2, or norm 1 I also need to change. You just double click and then it pump up edit graph and then double click the x-axis. You don't need to, okay, now uncheck the auto scale range. And it goes from C0 to 50. Now we have norm 1, norm 2, norm 1, just copy. So the whole purpose here, I like to show you, yeah. So this is norm 1. And then norm 2. Copy, graph. So in other words, two random variables, if you add together or you subtract the difference, the combination, linear combination, your variance will be getting larger. Okay? See, this is quite narrow, right? It's around the majority of data between 0 and 20. And for the norm 2, the variance is a little larger. The standard deviation is 4, so the range. But now if you add them together, see? So the range from 0 to 35. So it's more spread out, right? So no matter it's add together or you subtract, you combine the random variable together, the variance will be getting larger. So this is what we observed here, right? This is more narrow, but you add together or subtract together, it will be larger. Yeah, I hope you can do the same 3 charts for you add these two together, you will find the similar thing, yeah. Okay, so this is for the combination of random variables. That's for normal distribution. Okay? The problem we work on for the binomial distribution. Suppose 5% of Cal Poly students had lunch at Subway in the last 30 days. 10 students random selected. X represent the number of students had lunch at Subway. X number of people had lunch. Out of these 10 selected, what's the distribution of X? We know X follow binomial distribution, right? The successful rate, the percentage, the probability success is 0.05. And we also know X value could be 0 out of 10, could be up to 10 out of 10. So what's the distribution looks like? So we can simulate, see, follow binomial distribution. We generate random variables. We generate, for example, 2000. Okay. So we go back to this one. We need to generate binomial distribution data. Okay. So we can go to the sameness, generate with calc random data from binomial distribution. So this time, say I want 2000 data points in column C. I just C5. Okay. A number of trial, I tried 10 times, like select 10 students. The probability they visited the Subway is 5%. Okay. So I just use binomial just to see 10 students. Okay. So out of 10 could be 0, could be C. If I try this experiment, I first experiment the 0 student. Second, 1 student 0, occasionally 2. Okay. So what's the distribution? I can use graph to show, see what the distribution looks like. Okay, so this is the distribution looks like. Okay. So I want the frequency become, double click, become relative frequency. Type, I use percentage. So 60%, most of 60% of time, I selected 10, 0 student went to subway. Or 30% time, 1 student, less than 10% time, 2 students, and very few beyond that, right? So this is the distribution looks like for this specific problem. Okay, click OK. So we change this to percentage. Okay, and then copy back to the simulation. Yeah. So what we want, we want to know this histogram. Okay. So the distribution just look like this. If you can generate a chart, that's good.